I know, but thank you for your reassurance. Um, all right, so we'll just pick it up here. So on top, you guys figured out that 810 can be a bit of an intimidating number, but it does kind of call out to you. And it's like, do you see me? I'm 81 times 10, like it's just screaming at you. So the top becomes root 81 root 10, which is just 9 root 10. And at this point, 9 and 45, don't take baby steps when you reduce. Try to think about, can I just go all the way with this? And I can divide them both by 9, go big or go home kind of thing. So if you divide the 9 and the 45 both by 9, the 9 becomes a gone invisible 1. So we just get 1 root 10 over 5. Everybody, okay? Okay. Because I reduced this fraction in the blue box, I divided both of those numbers in the blue box by 9, because that's how we reduce fractions, is we just divide numbers by as much as we can. 9 divided by 9 is 1, but I don't put ones where they don't need to be. All better? Yeah. All right. On to question 4. And question 4 is, hey, guess what? If anything, when you see your quiz tomorrow, I will probably shorten this section. I don't think I need 6 of these. You'll probably see 4. I feel like 6 is like, all right, we get it. Like we're just torturing ourselves at this point. So I would probably cut this section down because I'm already getting bored and I'm only on the 4th one. So we're going to multiply the top and the bottom both by just the root. Please only multiply by what you're trying to accomplish, and that is just the root. So um, can you ask DC to bring his phone up here for me, please? Thanks. This job's hard enough when you are paying attention, and then when you're not, it's like, dude, come on. Although, in fairness, I should have probably said before that you're not supposed to be on your phone, so that was my bad. When I multiply, oh, I'm so glad I got that sarcasm on recording. Bam, I need to record more sarcasm. No, just so I can, just it's like therapy. Yes, a remix. I like this. What do you call that? A mashup. The Ahern sarcasm mashup. So we're on top, we're going to get the root of 60. Like I said, the top is just a math problem. You just multiply the roots together. You get what you get. You don't throw a fit. The bottom, when your roots cancel, so to speak, you get 10, and then you multiply that 10 by the pre-existing 6, and you get 60. So step 1 is in the books. Step 2, remember, is to break down the root. And so the root of 60 should be root 4 root 15, which is 2 root 15. I mean, the steps are just really repetitive, aren't they? And then you reduce the 2 and the 60, divide them both by 2. Kale, the 2 is going to become a 1, so I'm not going to put it. It's going to be the square root of 15 over 30. Everybody good? Primo? All right. Let's head on down to the southwest over here to problem number 5. Hey, guess what we're going to do? I think we should try something new. Let's multiply the top and the bottom both by root 3. So on top, we get 3 roots of 12, and on bottom, we just get 3. And at this point, if you wanted to cancel the 3s, you could, but just to stick with being consistent, I'm going to avoid that, and I'm just going to go break down the root. I want step 2 to always feel like step 2. So what is the square root of 12? It's root 4, root 3, which is 2 root 3. So when you say things like 3 root 2, it makes me want to punch a baby, right? It's not 3 root 2, it's 2 root 3. Make sure you are true to that process. When you put 2 root 3 back in where the root used to be, your top now becomes 6. And again, I'm going to draw a blue box for your educational convenience. These two numbers now are what's in play. The root's out of play. He's dead. But what is 6 reduced by 3? What's 6 divided by 3? This is 2. And I don't need a fraction anymore because when the top divides evenly by the bottom becomes pointless. And so we just get 2 root 3. Last one of this section, thank goodness. Woo-wee. What are we going to do?
Multiply by 6.
By what?
6.
There you go. Good. And what are we going to get, Chance? I like 3 root 18. I do not like putting. There you go. Good. All right. Good. 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 You recovered both times. So well done. And at this point, step 2 should just feel like step 2. What is step 2? Good job. Nice job. So when we make that into 3 root 2 and we re-inject it where the root 18 used to be, we wind up with a nice clean 9 root 2. And, I let you use calculators and work, those sheets with all the numbers on them. Either way, you all should have figured out that 9 and 42 can be divided by 3, right? Which means that it reduces down to 3 over 14. I mean, now's your chance because I'm here and you're here. So do you have any questions on 1 through 6? Yes. The steps are never going to change. Ever. All right, let's head on down the line. Let's head on down to problem number 7. And these are the problems. This is why we do practice quizzes, because it's not fair as a teacher to think that you guys would remember something that we did 2.5 weeks ago. So these are the problems, remember, where you want to add them together, but you have to try to make them look the same if you can, meaning like they have to have the same types of roots. And you can't put root 2s and root 8s together, but you can take this root 8 and make it into root 4, root 2, also known as 2 root 2. I'm showing a little more work. I haven't been showing this every time, but then when I re-inject that back into the problem now says 2 root 2 minus 6 root 2. If you replace this red box in place of, follow the arrow, in place of that red box, you'll see exactly where I got 6 root 2. And now you go, hey, sweet, I can add those guys together because they're both root 2s, and 2 minus 6 is negative 4 root 2. Question number 8 is really just kind of more of the same. This time the only difference is I have to break down multiple roots. But if you're not good at this by now, you just, keep trying. You got to get there. This is one of the non-negotiables, really. So the root of 54 can break into what? Root 9, root 6, 3, root 6, which turns this into 3 times 3, 9. Okay. 1 down, 1 to go. How do you break down a root 24? Root 4, root 6, becoming and 9 apples minus 2 apples is 7 apples. Well, you guys still perfect? You don't like breaking down roots. You never have. Do you have a hard time still with the trees where we find the 2 numbers? Yeah, it's just going to be a hindrance for you until you've got when a number like 54 comes up. So when you look at your cheat sheet and you see the number 54, and you're going to see a bunch of factor pairs. One of them is going to be 1 times 54. One of them is going to be 2 times 27. One of them is going to be 3 times 18. And one of them is going to be 6 times 9. And it's your job, Big Primo, to know which of them is useful and which of them are useless. 1 and 54 is dog water. Why? Because you can't get a good root out of 54. 2 and 27 is dog water. Why? Because you can't get a good root out of it. 3 and 18 are dog water. Why? 9 and 6 are cha-ching, because which number do we love? We love the 9. Don't care about the 6, but we love the 9. So when I take the square root of 54 and I break it down, I put my blank square root signs because I know how to follow my own directions. And then I put the one that I love in the first root, and I put the leftover, like whatever kind of thing, in the second root. What is the square root of 9? And I write 3 root 6. If that's a struggle, then that entire section will continue to vex you, because that whole section is really just about break down all the roots as much as you can. And then when you're done, do you see, Kale, how once the problem's over, how they both have the same type of root? They both have root 6s. That now makes them addable or subtractable. Yeah. The front numbers, yeah. So 9 roots of 6 minus 2 roots of 6. If you had 9 roots of 6 in your pocket and you were like, here, Mr. Ahern, I owe you these, and you gave me 2 roots of 6, you're like, oh, I have 7 roots of 6. So all that section is break down the roots, put them together if you can, you get what you get. Let's go again. Problem number 8, más práctica. How do we break down the square root of 24? 6 and 4, 4 and 6. And so when I break down the square root of 24, I break it into the square root of 4 times the square root of 6, which is 2 square roots of 6. And if I re-inject that into the problem, it will say negative 2 roots of 6. Done. Always. And it's not like it's wrong if you don't put it first, but I'm just telling you, I would always put the good one first, because then my answer comes out in the same order as the way I wrote it. Okay. Then I get to the second part, and I cannot break down the square root of 5. Therefore, I'll just copy minus 2 roots of 5 into my answer. That's a freebie on the house. Stay awake today. As tired as you are, I would just like to remind you and notify you that there's a decent, like 94% chance that I'm twice as tired. And I bet he's 3 times as tired, and he's tired squared minus 9, but none of us have the right to sleep through this. Use your neck muscles, keep your head up of its own free muscular work, because any sorts of postures like this are going to lead to sleep. This is boring as hell. Don't think I don't know that. But you have to stay awake. So I'm not doing this for my health. Assure you of that. Now we got to go break to, hey, we've seen this guy before, Big Primo. Look who we got again. We got the square root of 54. How do we break down the square root of 54? Yeah, so 54 is going to shoot down into root 9, root 6, which becomes 3, root 6. And if I re-inject 3 root 6 into this red box, see how there's already a 2 in front? So that 2 is going to multiply by that 3. 2 times 3 makes. And there we go. Pre-existing jailbreaks multiply by newbie jailbreaks, and they multiply to make a bigger jailbreak. That's all there is to it. And now I look across the way, and you get what you get, and you don't throw a fit. I look and I go, hey, I got some root 6s I could put together. That's pretty nice. So I'm going to take these 2 in the blue circles and say, you guys can go together to make negative 8, root 6. And then that other guy's like, whatever, weirdo, I'll just copy you down. One of these things is not like the others. So whatever. Still good?
Mm-hmm. Yeah.
Right. Last one of these, and then we'll get on to the equations, and then we'll be done. Question number 10. I wrote this problem so that they would all go together. So the program that I use doesn't do a very good job of ever giving me ones like this. I have to sit and hit the space bar. Space bar regenerates problems, and I got to sit there and hit it like 100 times. And then I get to hitting it so fast that when it finally gives me one, I skip it and I go, oh. So I just write it myself. I like problems like this where you kind of feel like there's a bit of reward at the end. So let's take a look at this problem. How do you break down the square root of 48? Yes. Root 16, root 3, which makes 4, root 3, which makes this 8, root 3. Multiply the jailbreaks. The 2, yes, that was already out of the root, and the new 4 that came out, yes, Gail, they multiply. All right, so let me erase some work and let's head over to the root of 12. How do you break down a root of 12? Root 4, root 3, 2, root 3. And you already had a jailbreak of 3. You have a new jailbreak of 2. 3 times 2 makes 6, root 3. And then finally, we have that last guy, and that is the square root of 300. What's the best? Yeah, root 100 times root 3. What's the square root of 100? Love that. Love those. Anything that ends in double zeros, love it. I'm going to pop out a big old 100. Love those. And then I'm going to re-inject that in, and it's going to say minus 10 of those roots of 3. So again, I try every once in a while, throw one of these in so that you can kind of feel that pleasurable sort of like reward. And you go, hey, that's a root 3. That's a root 3. Hey, I could put them all together. And 8 minus 6 is 2. 2 minus 10 is negative 8. So you have negative 8 roots of 3. So far, so good. See? All right, let's head to the last section. The last section is the equations, and they start easy and go to maybe medium, and then they take a pretty quick jump up to difficult. So question 11 is what we're on now. And question 11 ought to be like real quick. What do we do? Square, no, root, square both sides. And the reason we're squaring both sides is because we want to actually kill the square root. So if I square the left side, I get 9. If I square the right side, I get x minus 8. Add 8 to both sides, and you get your answer, x equals 17. And you don't want to commit to this yet. This is a naked answer right now. You don't want to leave it out there naked. You want to do one of two things. You want to put a box around it if you love it, or cross it off if you don't. Don't leave it up to me. So if I put 17 back here where this red arrow is pointing, what is 17 minus 8?
11.
17 minus 8 is 9. And what is the square root of 9? 3. And 3 does equal 3. So I'm going to say 17. You may have a box. You weren't. Next one.
Well, you put it into the square root side of the
You have to actually do the math. Yep. You getting all your questions answered today?
yeah.
Good for you. Appreciate that. I know there's at least a couple other people in this room who have them and are not asking them. So I just want you to know how much I appreciate the fact that you do that. Don't ever stop doing that. Ever. Not even when you're like 36 years old. You just be that guy. Don't nod your head politely. If someone says something, you're like, I'm sorry, I don't understand. You should just always be that guy. People like that guy. Those guys are successful. I'm going to square both sides. When I square the left side, I wind up with just negative 14 minus 2x. And when I square the right side, I get positive 4. And then I just do the math as always. So like how you approach this, me personally, I think I would add the 14 across and get negative 2x equals 18. And then I would divide and I would get x equals negative 9. And again, that's a naked answer. Put your pencil down for a moment, and then you just say, okay, I'm going to go back now and see what happens. He'll either work or he won't. And so if I put negative 9 back in place of where this little red arrow is pointing, I would caution you that this gets people, and I don't want it to get you. I'd like you all to get 100% all the time on everything. So what is negative 2 times negative 9? Positive 18. So what happens inside the root now is actually the square root of negative 14 plus 18. It actually became a plus. And what's negative 14 plus 18? 4. And what is the square root of 4? And does 2 equal negative 2?
No.
Therefore, x equals negative 9 gets himself across. What does that mean about this problem?
No solution.
And I actually need to write that down. No solution.
Oh, so you're going to do a 0 possible.
So for that,
Yeah.
some people do that. It kind of works. I would prefer that you just write no solution. It wouldn't mean the wrong thing if you put the little empty set notation, but whatever. Any questions on those? Okay, these next ones are just square both sides, and honestly, they're pretty simple because when you square both sides, there is no square square multiply double. There's just a root equals a root. And remember that crane thing I said that kind of stuck with some of you. When you square a root, it's like the crane grabs the root sign and just hauls it off to the dump, and just right. So when I square the left side, I just wind up with 9 minus b. When I square the right side, I just get 2b minus 6. And then it's just poof. It's a little baby pre-algebra equation, and you're just not allowed to miss stuff like this. I'm sorry, but you're just not allowed to. So I'm going to add my negative b across to make 3 of those. And then I'm going to add my 6 across. And I'm going to get b equals 5. And you just check it. So if you put 5 in place of where these red arrows are pointing on the left side, what's 9 minus 5?
Well, it's 4.
What's the square root of 4? 2. So I have 2 equals. If I put it where the other red arrow is pointing, what's 2 times 5? 10. And what's 10 minus 6?
4.
Square root of 4 is 2. 2 equals 2. So I'm like, hey, 5, have yourself a box. It's all yours, buddy. Question 14 is honestly just more of the same. We're going to just square both sides. And again, the crane is just going to lift off the roots, and now it's going to pop a little baby equation. So square the left, you get 3x plus 36. Square the right. And again, having been the guy that probably taught you all algebra, I would be offended if you struggled with an equation like this. For real, like on an almost personal level. So we're going to add the 2x across to make 5x. And then we're going to subtract the 36 across to get negative 50. And then we're going to get x equals negative 10. And again, we have to make a decision. Do we like it or do we boot it? Let's find out. Surprised that there weren't more questions about this particular problem, but let's see what happens. If I take negative 10 and I put it where this little red arrow is, help me out here. The numbers. I don't get along with the numbers. I need your help. What is 3 times negative 10? What is negative 30 plus 36? And the square root of 6 is not nice, so I'm just going to write it like that. If you look on all the resources you have, you're not going to find the square root of 6 anywhere because it's a poo-poo number. That's okay. Let's do the math on the right side, and at least we can comparison shop to see if they match. I don't know what the square root of 6 is, but I know if another square root of 6 pops up, it's the same. So on the right-hand side, if I put negative 10 right here where the red arrow is, again, I'll draw this little box for your educational convenience. What is negative 2 times negative 10? Positive 20. And what is negative 14 plus 20? You're like, listen, I don't know what it equals, but I know it equals itself. So negative 10, have yourself a box. It worked. And of course, we saved the best for last, and that is the square square multiply double problems, which if you did assignments 13 and 14, you ought to be quite adept at this by now. So here we go. I anticipate questions on these. I just don't know. Here we go. On the left side, when I square it, what do I get? This left over here, right here.
K squared.
K squared. Ugh. Plus 4K.
Plus less.
Perfecto. If you put K squared plus 4, I'm going to send you to Mr. Dishman's office, and I'm going to ask him to consider some sort of like really firm disciplinary consequence, like 17 days of following the custodian around and cleaning gum out of urinals and stuff. So please don't do that. Anyways, and then when I square the right side, I just go, it's just a crane lift. So I just lift off and put 14 minus 5K. And then it's just a regular old equation, right? Move all this stuff to the same side, and that side that you choose should always be dictated by which side has the squared guy. So K squared is, hey, everybody, come on over. And so I'm going to add 5K. I'm going to subtract 14. And there it is. This is a quadratic equation. Any questions to this point? All right. Factor. When I factor this, I go into it knowing, not thinking, absolutely knowing that my answer will look like this because of the minus that's in front of the 10. I don't give a rip what's in front of the middle. If there's a minus in the back, I know there's one of each, right? And then I'm looking for numbers that multiply to make 10. And 2 and 5 probably come first to mind. It turns out, though, that you actually want 10 and 1. Because when you add them, you want to make that 9. So what are the answers? And they are still naked answers. They should always be at this level of math when we're solving equations. They should be out there in the naked until we commit to them, right? So let's take the number -10 and let's go put it back over here where my blue arrows. Let's start with this blue arrow here. What is -10 plus 2? Then I already know that -10 does not work. Remember what we said is if you get a negative number equals a root, you can always just omit that one because no matter what the right side comes out to be, it ain't going to equal -8. So maybe going to equal 8, but not -8. So -10, take a dirt nap. Adios. Let's test 1. So first blue arrow, what's 1 plus 2? Second blue arrow, what's this math? Like 5 times 1 is 5. 14 minus 5 is 9. Square root of 9 is 3. It works. So I'm like, hey, okay, have yourself a box. Every answer should be crossed or boxed, always. And there's one more, and then we're done. Oh, yeah. What a great time this will be for those of you who have questions. If you have questions here as we wrap up, what a great time to ask them and get some extra help, perhaps. When I square the left side, Chance, I want you to answer this because of that abomination that you said last time. So here it goes. I don't do this to put you on the spot. I do this because when someone says something so egregious and mathematically offensive, I like to give them a chance to redeem themselves. Because you're that guy, right? You want to get back on the horse. Let's do it. Yeah. Plus what? I'm sorry. You asking me? Are they? Don't stop saying square root. It's not the square root. It's 1 squared. That just means 1 times 1, which is 1. Okay, well, don't do that. Okay, let's practice real quick. You guys ready to practice? Here we go. This you don't have to write this down, but you can. What's 1 squared? Okay, I'm going to make this one a little trickier. What's 1 squared? Okay. No, this one. I am too. We're practicing. We're practicing. This one, you're going down. What's 1 squared? All right, yes, I don't know what to. No, it's -0. Yeah, listen, you dress it up however you want, put a little bow tie. I don't care. You just got to know that 1 squared is 1. -0. It's 3. For the record, I get where you're coming from too, but it doesn't change the fact that you just have to learn it and move on. 1 squared is 1. It's -0. Yeah, so we should probably move on now because people are just starting to say really dumb things and we're starting to waste time. So you boys, if you struggle with it, just write it down. Just at the top of your notes, the first thing you should write is, hey, dude, 1 squared is 1. Just write it down, and you always got it. So we have p squared and plus 1. Chance, what's going to go in the middle? Okay, -2p. I like it. And we're going to square the right-hand side. And what's that going to equal? Oh boy. And then from here, yet again, it's just a standard quadratic. The left side says, come to me. I, on the quiz, won't guarantee that it's always going to be left. You understand that we go where the squared is. We don't care left or right. We go where the squared is. So I'm gravitating over to the left side. I'm going to leave p squared. I'm going to subtract 7p. I'm going to add 17. And there it is. All that hard work leads to this.
Oh, you read it? Okay.
I'm sorry. Not on purpose. Because it's not a negative one, what you need to remember is that let me remind you of something, that this thing in the red box, and this is another thing that in a classroom where you're allowed to have notes, if you're even if you're anything other than 100%, write this down. Those are always going to be positives. The front and back are always positives. So if it's a positive one and we add 17 more, that's right. Yeah. I had a young lady took a quiz earlier today in first hour, and her notes, it was like 1/20th of a piece of paper, but she had just written down only the essential things. Like she didn't have this big color coded thing. She just said, these are the things I suck at. And she wrote them boom, 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 and aced the quiz. It was like, that's good, smart notes. So your notes should always contain things that you know are going to trip you up. Like 1 squared equals 1, right? You name it. So that leads us then to the factoring, the world of factoring, which is P minus and definitely P minus. And of course, the numbers are. And so my answers without boxes or crosses, bless you, are P equals 6 and P equals 3. So if I test 6, I'm going to use green arrows this time. If you put, I'm going to get rid of my.
-1.
If you put 6 right here, you get 5. And if you put 6 over here, what's 7 times 6? What's 42 minus 17? What's the square root of 25? 5 equals 5. So I'm like, hey, 6, have yourself a box. And then I'm going to test 3. Go where the green arrows are again, if you'd be so kind. On the left, what is 3 minus 1? What is 7 times 3? What's 21 minus 17? What's the square root of 4? Like, hey, you guys both work. You may both have a box.
All right, cool.
Yes, sir.
Go this way now.
Sorry, Kale, I need to answer this stupid question. You will turn in your practice quizzes with your quiz tomorrow. So make sure that you, of course, hold on to it. I'm sorry, what? Yeah, sure. I'll just keep recording in case. So I'll just write down whatever question you have. So what's up?
So you'll get the.
Sorry, Bubba, are you on an actual problem?
Yeah.
And which problem is it? So you want to just go through that with me again? Sure thing. Yeah. And I can write some more practice of these if you'd like some different ones. No problem. So tell me again, what did you do? Right.
Go over, you multiply it.
Yeah, so these two roots, you just put them together. Multiply is what I meant. Yeah. And then the 3 that I'm pointing to with an arrow, it just stays in front, but then the 2 roots join forces and make a bigger root. Are you with me?
Yeah. There's 3 on 1.
Right.
Yeah. 3 and 3 all together.
They can, but if you start going, yeah, if you're going to go rogue like that, I'm okay, but I just don't want step 2 to ever feel like, boy, I don't know what to do. I feel like step 2 should just always feel the same. Step 2 is break down the root. A root 4 and a root 3, which is what? So, Kale, I'm going to color code this. I really want you to pay attention to this. I'm going to take this yellow box and I'm going to replace it with the contents of that other yellow box. showing as much work as I can. So what that's going to look like is the top is going to be 3 times 2 root 3. Still feel good?
Yeah.
And then you're just going to multiply. I always call these guys the jailbreaks, the guys I've circled up there. They're the guys that kind of made their way out of the rootville. And what's 3 times 2? So I'm going to get 6 root 3 over 3. And then you're just going to reduce. Not the root. He's off limits, but just the numbers in front.
Can I get my phone back? No, grandfather just called me.
Hold on a second. I'm going to